Hey everyone, and welcome to our second lesson in the geometry unit, which is going to be on surface area and surface area of composite figures. This lesson is going to start off with actually a warm-up from yesterday's content. We have two different composite shapes. So composite shapes are just shapes that are really comprised of other shapes. So here I can actually see that I have a semicircle and I have a trapezoid. So it shouldn't be too different from problems that you had yesterday, but we do need to use a little bit of logic. So I have a situation in which I have the entire area. If I can find the area of that semicircle, which we don't necessarily give it a formal equation, but it would just be half the area of a circle. And then once I take that away, I basically should just have a trapezoid problem that was very similar to our worksheets yesterday. So I'm not going to go through it in its entirety here. We can take a look at it probably when you're in class, but that would be kind of how I would start tackling that problem. And this one's semi-similar in which the combined area here is 125 square units. And what I would do is try to create an area equation for this figure. And it's going to have, three different pieces. We have this parallelogram on there, we have this rectangle on there, and then finally we have that triangle. And because I know that the area is 125, I should be able to use that equation, which the only missing component should be x at that point in time, and then I can figure out what that missing dimension is. So also give that one a try. If you can succeed in doing both of these, then you're really right where we need to be in terms of understanding area and solving for missing components and things like that. So they're a pretty good test of sorts. Today, we're going to use area a lot, but also learn about some other surface area equations that really come from calculus. So the derivation of these is going to be a little bit trickier. One of them we'll be able to talk about, but otherwise it takes calculus in order to figure out basically the surface area of a sphere or the surface area of a cone without just having the equation. So we're going to be granted those equations and be expected to apply them, but just know that the derivation isn't something that we're necessarily going to see. So in this first surface area calculation, this is kind of what I consider our basic version. And this, if I were to label this, would be a triangular prism. So it's triangular in that I have two opposing triangles as my bases. Okay, so here and here. And then it's a prism in that the kind of width of this object doesn't change between bases. So oftentimes we're going to be differentiating between prisms and pyramids. And pyramids are going to be coming to a point, whereas a prism will kind of maintain that triangular shape the entire time. So if I have to do the surface area of this shape, what I really want to do is break it down into all of its components and then just find the area of those shapes. So sometimes I'll even write this out almost like I'm kind of ordering something. So I have two of these triangles on here. So those are the ones that I have highlighted. So I'll need to figure out the area of those. I also have this rectangle on the bottom. So I'm going to need to figure out the area of that. So that's 12 by 10. So this guy was 12 by 10. I can go ahead and put the measurements on this top one as well. So that is a 12 by 16 triangle here. And then let's see, what other faces do I have? So I've also got this rectangle in the back that I need to account for. Dimensions of that are 16 by 10. So I have a 16 by 10. And then I'm going to have one more rectangle, which is going to be that front face. So this is going to kind of cover up a bunch of stuff. But I see that I've got this front face right here, which is a 10 by 20. Okay, and once I find all of those areas, I'm just going to add them up, and that is going to be my total area at that point. So for my two triangles, they are 16 by 12. So this would basically be 1/2 12 times 16. And then because I have two of them, I could do this big 2 on the outside. I could also just cross those off. But the combined area of those triangles is 192. Then I have my 12 by 10. So this is 120, 16 by 10, 20 by 10. And I'm just going to be adding all of those up. So 192 plus 120 plus 160 plus 200, 672 is my surface area of this shape. So common applications of this are generally if we're painting something or constructing something, this is going to tell us how many square centimeters of material we're going to need. Pretty useful applications engineering-wise. Things get a little bit trickier when we start dealing with some of these curved figures. So here, if I have a sphere, okay, so that's my sphere with a radius of r. In order to figure out basically the covering on this, I have that my surface area here is 4 pi r squared. And there are a few understandable videos out there that don't get into calculus too much if you were actually, super curious on this, but it does end up just being the area of 4 circles that are that same radius, so that's kind of interesting. But otherwise, we can just kind of understand that if I have to find the surface area of a sphere, and the radius is 5 in any particular case, then I would just say, okay, the surface area of that is going to be 4 pi times 5 squared. Make sure that you're squaring that 5 first. And even if you just left this as 100 pi, sometimes that is preferred because it's as accurate as we can get with, not writing a lot of decimals. So then we have a cone. So this would be a cone of radius r. And here we're also going to be given, sometimes we're given the height, but in this case for surface area of a cone, we are more concerned with the slant length kind of being the interesting component here. And this really has two different components, okay? So we have the lateral surface area, which is basically just the cone portion of it, so it's not the circle on the bottom. And the lateral surface area equation is pi times the radius times the slant length, and I'll probably just highlight that again here. So L is the slant length, except let me adjust that. Okay, so it's not the height of that cone, it's actually the slant length. And then we also have this circle on the bottom that we need to account for, which is just going to be pi r squared. So to figure out the total surface area here, we have pi r squared plus pi rl. And that is going to tell us the entire covering of that shape. So that includes, basically the top of that party hat. All right, our last little fancy shape. And then I'll probably switch videos and maybe do one with a few example problems if we need. Your eventual assignment today is to probably try to complete maybe 4 of these problems. They're relatively involved, So, I don't need you to finish all of them, but definitely kind of get in, try to attempt them, try to struggle with them so that we have exposure to it by the time we get into class. So let's finish up with this cylinder. So right off the bat here, with my surface area, I have two different circles. Okay, I have the top and bottom of my cylinder that I need to account for. So I'm going to have 2 pi r squared as part of my equation. The other piece of this comes basically if I unwrap, okay, if I were to cut this can here and then basically unwrap it. Okay, so I'd get this, and then in theory, I'm also going to get, the top and bottom of my can. So this is pi r squared, this is pi r squared, and then this is going to be, we're not quite sure what this is just yet, but we're going to figure out an equation for the surface area of this. So if I'm given the height, which I generally am in these problems, I've actually created a rectangle here where I have this height value, and this distance is also, if we kind of take a look at unwrapping this up here, that distance is also the distance around one of these circles. Okay, so if this is a rectangle, the base of this rectangle or the width of this rectangle is going to be 2 pi r. And that's because, this is the equation for our circumference of a circle. So if I want to figure out just the area of that rectangle right now, I have 2 pi r h, which allows me to finish my surface area equation up here. So it's 2 pi r squared because of the two circles, and then plus 2 pi r times my height. And that is going to determine the surface area of the entire cylinder, but also the 2 pi r h is generally we would consider that like the area of, sometimes it's called the label, but it can also be called the lateral surface area as well. All right, so those are our equations. Just to kind of highlight them again, we have for a sphere, pi r squared. For a cone, we have pi r squared plus pi r L. So two different variables that we would need to know, the radius of the cone and the slant length of the cone. And then for a cylinder, we have our final equation, which is 2 pi r squared plus 2 pi r times h. And again, we need two different pieces of information there. We need to know the height of the cylinder and the radius of the cylinder. All right, so like I said, there's going to be a collection of problems down here. And once you get the hang of it, there's definitely varying degrees of difficulty on these problems. So try to choose ones that are interesting to you, or if you think you're going to be able to find success with it, then choose something that's a little bit harder. So this shape is called a frustrum, which I think would be valuable for folks. But yeah, find some problems that you think are in your wheelhouse and look to complete 4 of them. All right, thanks everyone.